Stoneham, who is going to present a short talk on writing your own Go compiler. Thank you.
Hello. If I'm not loud enough, I am able to be loud. So for those of you at the back, if I get a bit quiet, would you please tell me? Don't be shy. I'd rather you could hear what I'm going to say. I'm very old. I think you can see that. And 30 years ago, I fell in love with the C programming language. The Kerning and Ritchie book was an absolute revelation for me. And then 20 years ago, I stopped programming. Can you imagine what a dreadful thing that is? I stopped programming. I went into IT management and general management, and thankfully, a year ago, I found Go. I found programming again. And it was the same feeling that I had about when I had that K&R book. That same feeling of, this is just amazing, it's so clean. So that's part of the reason why I'm standing here. But the reason why I'm giving this particular talk is because I wrote an application for App Engine, and inside my application I had some logic, and what I really wanted to do was to get that logic inside a client-side application in a browser initially. And I was faced with the horrifying prospect, frankly, of having to move it into JavaScript. And I just didn't want to do it. And on the basis that if the tool doesn't exist that you want, you should go and write one, I decided to give myself that challenge. I want to see Go everywhere. I want to be able to use Go for everything that I do. Maybe I'm just lazy, maybe I'm in love, who knows. So what I'm going to talk to you about today, first of all, is really a little bit about the Go language and the various compiler projects that are around. Secondly, I want to sing a hymn of praise to Go tools and talk about how you can use Go tools to build your own Go compiler. Then I want to talk about the prospects for using those mutant Go compilers to create code that runs on the client side. And finally, although I can't teach you how to write your own Go compiler, I can at least give you some signposts. So I hope some of the things I'll talk about, some of which are horribly nerdy, will be of interest to you. So what's success? What does success look like for me? Well, clearly, what I'd like you to do, I hope you'll be inspired to go and write your own compilers. If you don't write your own compiler, I'd like you to help somebody else write a compiler. And if you don't help somebody else write a compiler, I'd like you to at least go and try one of the compilers that are out there, because there's a choice. First, a little bit about the language. I can't actually prove this. I can't make a logical proof. But I think that Go is the smallest language for specification for the largest number of features. Does that ring true with anybody? And it's that smallness that makes it such a joy to use and makes it so readable, and I think with my management hat on, makes it so cheap. Because maintainability is much lower, and as any manager will tell you, it's the cost of maintaining the systems that tends to be hideous. But it also makes the language relatively easy to implement. And I think in that way, perhaps unwittingly, the Go team have created a very portable language specification, a very portable language. So the compiler projects that are out there now, clearly there's the the two from the Golang team themselves. There's a closed source compiler called Toolgo that's being built, which I'll give you a link to shortly. And then there's the three open source compilers that are coming on: LLGo, Go4JS, and my own TARDIS Go. So the next talk is about Go 1.3, and there's a couple of, and I can't, you know, clearly they'll do a better talk than me. The two things that I think are really important and validate what I'm saying today are, first of all, a Go compiler can be written in Go, everybody. Woo. And secondly, auto-translation is feasible. If you're interested in this topic, the Toolgo blog, written by someone called Atom Symbol, who may or may not be male or female, is worth a jolly good read. It's a good read. Have a look. Going on to my main topic, the mutant Go compilers. There are three. LLGo targets the LLVM architecture, written largely by Andrew, who is in Australia at the moment, sadly. Go4JS, though, targets JavaScript, and it's written by Richard. Would you stand up, Richard, just so everyone sees? So if you've got any questions, I'd be very grateful if you'd ask him. And my own TARDIS Go, which targets these seven different target environments. As you can see, they've been around for various lengths of time, mine for the shortest time and LLGo for the longest, which is why it's got so many contributors. My hymn of praise to Go tools. I was trying to find a way to say why is it so good, and what came into my mind was Howard Carter looking into Tutankhamun's tomb. Because when you peer through the gloom and someone asks you what's in there, you say, wonderful things. If you're sad like me, there's just so much great stuff in there, much of which I don't even use. And as Matt pointed out earlier, whoever Matt is, the Oracle tool is for me like Tutankhamun's mask. It's the greatest artifact within there. It lets you ask questions about Go code. Questions you didn't know you could even get an answer to, it will answer. You just point at a piece of Go code, it gives you the answer. And Pythia, incidentally, Pythia was the high priestess of the temple, the Delphic Temple of Oracle. Oracle, yes. Is the way I would use to look at it. The Oracle tool uses a number of libraries, and they are collectively, to my mind, the first 2/3 of a Go compiler. Most interestingly for me is the SSA intermediate representation. Now, what the SSA intermediate representation does is it models your entire Go program inside 36 instructions. And within SSA dump, which is a utility, you can actually run an interpreter that will interpret these 36 instructions. So if you take, as TARDIS Go does, if you naively translate each of these 36 instructions into a lump of code, voila, since we're in Belgium, you get a working program. Amazing. So here's a little example. It's a factorial program in green at the top, and at the bottom is what the stringer representations of the data structures with the SSA form. I had to explain to someone at a previous meeting that it doesn't actually look like this. The SSA form is actually a lot of wonderful interlinked data structures. If you want to see that for yourself, you can go to this address and put in a random bit of your own Go and it'll print it out. Or you could run SSA dump, the SSA dump tool. So the three mutant compilers use these sequences. You can see that for LLGo and for TARDIS Go, we both use the pink standard Go library stuff to generate our own intermediate form. For TARDIS Go into HAX, for LLGo into LLVM bitcode. Whereas Richard here does the really clever stuff and does it all straight from the AST. And as a consequence of that, he doesn't have GoTo. So there's some minor elements of Go that the Go language are missing. Is that major? Is that really important? So let's talk about the prospects on the client side for each of these, since that's where I started with this whole thing. For LLGo, as you can see on the right there, it's got through to the point where it can create a Pinnacle Hello World program. So this is importable NaCl. But unfortunately, it's not got any further yet. It's very close, but it's not got much further. So the prospects for LLGo are that you'll be able to run at almost native speed inside Chrome and in emulated mode using the same interfaces using Emscripten and Pepper.js. So it should become a viable way to run very fast code in the browser. Unfortunately, because it's not there yet, I can't give you a little demonstration. Happily, with Gopher.js, I can give you a little demonstration. And I'll go straight to it, shall I? So, there is a wonderful game engine that's been written using Gopher.js, and I'm going to just mess about on here and give you a little demonstration of it. Okay, so up in the top left, it's giving you it's giving a frame rate up in the top left, and it's going to do, and this is all written in Go. Every time I click, please, every time I click, it's going to introduce some more bots bouncing around on the screen, all in Go, translated to JS, and maybe it's going to reduce the frame rate as I put more in. Not noticeably so far. It's just too good, I hate it. You get the idea. Please, go and look. Okay, moving on to my own little project. On the client side, TARDIS Go is targeting a wider set of clients. So it's not only targeting the browser, HTML5 and Flash, but also desktop clients and handheld gadget things. It does that by translating into the HAX language. So it takes Go and generates HAX. HAX is a wonderful, mostly French project that translates this HAX language into these other 7 forms. And here's our factorial example again. This time with the green Go code going into the white SSA code and then going into the, is it pink, HAX code over on the left. And the HAX code, unfortunately, isn't data structures. It does actually look like that. And here's an example of that same Go code running factorial 10 in all of these different target languages inside JavaScript, C#, C++, Java, PHP, and Flash. That's not very exciting, showing you, I mean, it excites me, but, but just seeing it all off the command line is not that great, is it? What you really want is to have a tool that lets you use it across all the clients you might want. So OpenFL is a Flash clone that allows you to use the Flash API on all of these different clients. And what I've done, I'm going to show you an example in a minute, but just to preface my example of that, there's a great talk by Rob Pike called Concurrency is Not Parallelism, which was mentioned earlier actually, about burning C++ manuals, allegedly, where one for going from the pile of C++ manuals, one gopher takes it to a staging pile, and then another gopher takes it forward and puts it in the furnace. all running wonderfully in parallel. Or in fact not running in parallel, running concurrently I should say. So hopefully here's my envisioning of that. Okay, I'm going to have to take a bit of time just to explain what's going on here. There are 16 Go routines running here. There are 16 Go routines. There are 4 Go routines, one for each of the stack, and they're using the select function that was talked about earlier, where you do a randomized select. Now that randomized select is generating random loads. Then there's another 4 over here, which are the furnaces, and they're just taking those loads and burning them. Each load's just an integer. And then in the middle here, the pile that occasionally appears is actually the state of the channel between the 2 Go routines, telling you whether it's full or empty. Now, each of the gophers is actually running the code you see in the middle at the top. That is the actual code that's running. You can see down the left and right side of that code, there's a little mini gopher going up and down, showing you which bit of code it's currently in for the 2 gophers above it. And you should be able to see that at some points the gophers have to stop because the pile's empty or full, depending on their state. Now, the point of this is that it works not only here on C++. Now, that's a bit of a paradox, isn't it, because we're burning C++ manuals. But it also works online. If you go to the website, TARDISGO GitHub.io, you'll see the same thing running in HTML5 using JavaScript, and if you go follow a link, you can see the same thing running in Flash. So, you know, go and have a play. That's about it. Okay, thank you. Whoa! Go me. Yeah, sure.
Take questions.
Yeah, do you
Any
want
questions?
Yes. We've back in this when you run, for example, this algorithm on the PHP, JavaScript, Java, which one do the results depart?
I'm going to come on to some benchmarks in a minute, but Java is actually the best.
Oh, he's still. You're not finished yet.
I'm not finished yet.
Oh,
No,
keep going,
sorry.
keep going. Sorry.
I've got more time, haven't I?
Yes.
Yeah. No, sorry. It's back to the boring slides now, guys.
Was that JavaScript we were seeing in the browser, running the buffer?
No, that was C++. I'm running natively on my Windows machine here.
Okay. Is it able to run on JavaScript?
Yeah. If you go to the website, you can see it running for yourself.
But JavaScript is single-threaded, so...
Ah, good point. Yes, and I'll come on to that because I have to simulate Go routines. Okay, now I think that primitive optimization must be the root of all evil, which is why I've done a very simplistic code generation. as I said earlier. And that has an effect on the relative performance of the various systems. So you can see two different benchmark programs out of the Go library, chosen at random pretty much. At the top there you can see what Golang Go itself does. Then you can see what LLGo, Go4JS, and various of the TARDIS Go targets do. Now, as it says in the title, it's important to realize that these results are skewed because they're all works in progress. So, for example, for the LLGo compiler, it doesn't do range checking at the moment. So it performs a little bit better because it isn't doing range checking. However, in the way I compiled it, I didn't use all of the LLVM optimizations. And I've seen figures that suggest if you do use all the LLVM optimizations, it actually runs faster than native Go. So I think it's one to look out for.
One question to the diagram. Is just the lambda.go color wrong, or are both colors wrong?
I'm sorry, it's the color of the top floating point. It's the left-hand one is the red one. The red one's the blue one. Obviously, when I translated, it's in PDF this, and when I translated it, obviously it muddled the colors. I'm sorry.
No problem.
So Go4JS isn't at the moment using Go routines. That's my only hope, that it gets slower when you use Go routines. I think it's absolutely remarkable that Richard's managed to get it going at half the speed of proper Go this early in the development. And as you can see, for TARDIS Go, Java's the quickest. I haven't put PHP on here because it's sort of over here someplace. I've got some work to do to speed things up, but I've absolutely no doubt that things can be speeded up. So, the question that someone posed about Go routines. If you've got threads, wonderful, you can use threads, and the simplest thing to do is to use obviously one thread per Go routine in terms of generating code. If you haven't got Go routines, as TARDIS Go doesn't have, you have to use coroutines and keep a pseudo stack for each of your coroutines. I actually use the SSA block number as a program counter. That's my top tip. But there's a strong argument for not having Go routines at all in some circumstances. If you're making a callable library, and I think much of this cross-language work will be around callable libraries. If you're doing that, then I think there's a very good case for not having Go routines because it's going to make it much faster, probably. There are some type issues, as you would expect, between Go, JavaScript and hacks. There's no small floats. If you've got small integers, you've got to mask them and sign extend them every time you do. This is the same problem that Emscripten has when it compiles C to JavaScript. Similarly for int64s, you've got to emulate them on some platforms. String can be different. A string on one platform can be a different encoding to another platform, and you've got to work around that. But one of the biggest issues is memory and pointers. Clearly, some of these platforms don't have pointers, and you've got to actually emulate it in some way. Emscripten does it by creating an array, which is the memory. But the problem is that when you try and do that, the various garbage collection activities can collide with one another, so it's really awkward. So what we've both done in Go4JS and TARDIS Go is to actually think of each lump of memory as a different object inside the host environment, and let the host take care of the garbage collection. So the way we do that is TARDIS Go, which has to work across 7 platforms, does it very, very simply indeed. It's all arrays of dynamic objects all the way down. Each dynamic object can have other arrays of dynamic objects within it, and so on and so on. That's at the moment. I'm going to follow the example of my illustrious friend who's doing Go4JS and make it a bit more sophisticated than that. Adding sophistication so that you do deal with the type information also means that you have to, for a TARDIS Go, it has to be specific to a particular target. The bête noire of all of this is unsafe pointers. Fine if your memory model is as it is, but if your memory model, Richard kindly wrote this for me, if your memory model is such that you haven't actually got anything in memory that looks like the Go model of what's in memory, you have to do a lot of simulation. You have to deal with a lot of special cases if you want to make the Go standard library work. Or you can think of unsafe pointers as an invention of the devil, like I do, and not do it at all. So, I've spoken about unsafe pointers being one of the issues with the standard library. Another one is that there's quite a lot of functions in a C or assembler in the standard library that you need to write, more than I was expecting. Also, the standard library can produce very large code. Does anyone know how large a Java function can be before it blows up? I can tell you it's 64K of Java intermediate code, and I hit that with the init function for Unicode. So you have to do some, what I'm saying is you have to do some working around on the code. There's also the issue that if you've got a lot of compute function going on in 32-bit integers, for example, sorry, in 64-bit integers, for example, and you're running on the browser, you probably don't want to run cryptography. It's going to go mighty slow. And of course, there's some things just are absent. Some functions are just absent. Okay, so Go4JS has got a great system for getting, I'm nearly there. Go4JS has got a great system for getting at the DOM and various other things. I nicked this from, this is code actually out of you saw the bots all bouncing around the screen. This code's from there. As you can see, right at the top line is JS.global, which allows you to get direct access into JS. So really neat. Obviously, TARDIS Go's is equally neat, I'd like to think. It uses the HAX libraries, and it uses the convention that any package that begins with an underscore is actually a HAX package. So you can describe that HAX package in Go and include it in the normal way, and a TARDIS Go compiler works it all through. The wrinkle is that HAX as a language allows you to take an XML description of all of its functions, and so this can be auto-generated from the HAX. So interworking between the two languages should be fairly straightforward once I finish it. Okay, so just to review, I've spoken about Go. It's a really portable language, honest. The Go tools repository is just, I mean, just as the whole language is full of gems. There are particular gems there. If you haven't gone mining, then you really should. These mutant compilers, well, I hope you think they're worth a look. And I've spoken about some of the design. Please, I came here to get some of you to look at this. I came here for some of you to help to make it. Please, help me. But it would be an absolute wonderful result if one of you was inspired to go and write your own? Look, if someone who's only been programming again for a year like me can do it, I'm sure you guys could do it. Stand on your heads. Any questions?
Thesis is actually about writing your own integrator for an ERP system and interact language specification and integrator and so on and so on and so on. Language needs to be simple to use because the customers aren't necessarily building it. We have an
If I were to do that, I'd write that. The way to use these sorts of systems to do that would be to write it in Go, write it in a subset of Go. Yeah? Give them a subset of Go.
Which parts of Go are not implemented in your translator? Are any part? Besides the flow 32 and stuff?
What's not there? There are various bits not there because I've not written them yet, but I can't think of anything that couldn't be there, if you see what I mean. So I haven't written reflection, but you have written reflection.
Is select all there?
Yeah?
So you should wake up Russ Cox. He said to wake him up when anyone implements select. Besides encoding gob, is there anything else that's using unsafe that is annoying? Like, if we made safe versions of all this stuff with like a build tag, like build tag safe, that turned off the unsafe use, would that be useful?
That would be fantastic. Yeah.
What else did you hit besides encoding gob?
Richard, do you got anything? I haven't gone through the entire library yet, so I'm.
Yeah, encoding gob is the worst because the net package, you don't need that when you want to run code in the browser, so that doesn't count.
Project from Red.
Anybody else?
I think we're out of time.
Okay.
Thank you.